Okay, today I want to finish section 1.3 because I didn't finish section 1.3 today. The one more I want to give the same problem on today lecture because so I need to explain the more things. I can start the slide number 11 together. So you can find this lecture note on Canvas section 1.3. Let me see. Here. This is today problem. Let the vector v1 is like 2 on, vector v2 equals level 2 and 2. Express a and b as a linear combination of vector v1 and the vector v2. So how can we solve this problem? We have two methods are possible. The first method is geometric method. The second method is like algebraic method. I will explain the solution of this problem by using the geometric method first. So how can you do that? So first, you can draw like a line. You can plot 1, 2. This is like 1. We have 2 and 1. So this vector is exactly vector v1. This is a vector v1. So what's it like a v2? There were 2 and 2 here. The negative 2 and 2. So we have here this one. This is vector v2. So what's it like A03? The 03 is here. This is this one, vector 03. This is vector A. How can you express vector A by using vector v1, vector v2? So another one is like vector B. Vector B is -4. So you can keep going more. The 3 and the -4 and -1. We have this one. So we have it, this part. So like this. This is like the vector B. B. So what's like main idea? You can use a parallelogram. So the vector is very clear. You can make the parallelogram by using vector v and v2 exactly vector A. What's like a second one? You have to expand this one to the here and vector v1. You have to make a parallelogram. It's like a parallel to the vector v2 here, parallel to the vector v2, this one. So make the parallelogram. So what does it mean? So we have this vector and this vector. You can combine these two vectors exactly vector B. So my point is, what is this length? What is this length? Compare with vector v1. Just like length is 1, what is this length? So far, not easy to find exact length. Same thing. This whole length is the length of vector v2. What's the length of vector v1 compared with vector v2? This one, this length. So how can you find these kind of things? We have one good idea, like this one. The one good idea is, this is like exactly today lecture. So you can draw vector v1 here, 2 and 1, here. This one is the vector v1. You can extend this v1, and you can draw a lot of like parallel lines here. A lot of parallel lines passing through to like this. Here you can draw a lot of parallel lines. Draw parallel lines here. You can draw a lot of the parallel lines, like this. The next vector v1, exactly 1, 2, and 2. So we have this one. So same, you can draw line. So you can draw parallel lines. You can draw the parallel lines, the passing through the x-intercept 1, -1, 2, -2, or something like that. You can draw a lot of the parallel lines like this. Like this one, you can make it, this kind of things. We have this one, like this. So what does it mean? So here, vector v1 is here. This is vector v1, the 2 and 1, vector v1. Vector v2, so we have 2, 2. So we have here. This is vector v2, vector v2. You can draw vector A. Vector A is this point. So we have vector A. This is vector A. So this is very clear. So vector v1 plus vector v2 is, you can draw parallelogram, so like this. So exactly vector A. This is very clear. So we have vector A is vector v1 plus vector v2. This is very clear. I can confirm. The vector v1 is like 2, 1 plus vector v2 is -2, 2. You add these two vectors, we have like this one, 0 and 3. Yes, the 0, 3 is vector A. It's very clear. The next one. The next, so what is it like -4 and -1? This is like -1. This is 1, this point. So how can do that? So from here to here, this vector is vector B. So vector B, this one. So same. How can you find this one? By using parallelogram. The parallelogram here. This is one part, this one. The another one is here. These two vectors, you can make a parallelogram. So we have this point. What is this vector? By using vector v2. Vector v2 is here. The how many rectangle? How many some the small parallelogram do you have? 1, 2, 3. The 3 parallelogram. So this portion is only 1 out of a third. So what's that? So this vector is exactly same to 1/3. The vector v2. So we have it. What is this vector? What is this vector? So here, vector v1 is this direction. This vector is opposite direction, exactly negative number. The one more. How many rectangles, small rectangles do we have? The 1, 2, 3. This is 3. What's that? This is 1, 2, 3, 4, 5. Exactly 5/3 is right. We have a 5/3. This is exactly same to -5/3 vector the v1. So what does it mean? This is like a diagonal is exactly sum of two vectors, the 1/3 v2 minus the 5/3 v1. So we have vector b is same to -5/3 vector v1 plus 1/3 vector v2. I want to confirm. This is the right one. So -5/3 times vector v1 is the 2, 1 plus 1/3 times vector v2 is negative 2 and 2. So we have it. This is the negative 10/3, negative 5/3, plus the 1/3 times negative 2 is negative 2/3. The 1/3 times 2 is 2/3. You added these things exactly negative 12 over 3, negative 3 over 3. So what's that? The negative 12 over 3 is minus 4. The negative 3 over 3 is minus 1. Yes, exactly same to vector v. Yeah, that's it. This is like a geometric method. The next one. Now, how can I solve this problem? So we use algebraic method are possible. So vector v is linear combination of v1 and v2. So what does it mean? The next one. So vector v here, vector v is the same to linear combination of two vectors v1 and the v2. The first scalar corresponding to v1, you can write x1. So x1 times vector v1 plus x2 constant times vector v2. This is exactly the linear combination. What is x1, what is x2? The real numbers, like a scalar, the scalar. So you can use this one. What's it like x1? x1 is unknown times vector v1, 2, 1, plus x2 times vector v2 is negative 2 and 2 equals vector b, the negative 4 minus 1. So what's that? You can change this one to the only matrix form. So first one, 2, 1 is first column, 2 and 1. Second column, negative 2, 2. So this is x1, x2 equals negative 4 minus 1. Exactly linear system. The linear system ax equals b. Ax equals b form. So how can you solve this equation? You have to solve this linear system, solve for x1 and x2. So how can you do that? I want to use augmented matrix. We are going back to section 1.2. So we have augmented matrix is like so form. Then change the augmented matrix. The augmented matrix is like this. You keep first column 2, 1, negative 2 and 2, and b, the minus 4, the negative 1. So next tip. I want to change the first row, second row. This is like better. The first row has 2, second row has 1. You can interchange 1 and 2. This is like echelon form. You can change the echelon form. So we have 1, 2, minus 1, so 2, negative 2, so minus 4. You can change it like this. The next tip. You can eliminate this 2. How can you do that? So this is like a first row. So this is like a second row. We can use this one. The second row plus the negative 2 times first row. The second row is 2, negative 2 minus 4. Was it like a first row? 1, 2, negative 2 times negative 2, the negative 2, the negative 4, and positive 2. So we have like this. This one, and add it. And add it. So 0, negative 6, and 2. We have this one. Oh, negative 2, sorry. Add in negative 2. So we have the first row, same. 1, 2, minus 1. The second row is replace. by new things, 0, -6, and -2. So this second law is like this one from here. The next, you can eliminate 2 to the 0. How can you do that? Same. This is like first law. This is second law. So how can you do that? The first law plus the 1/3 times second law. The first law is 1, 2, -1. The 1/3 times second law is like 0, -2, the -2/3. And add. So what's that? 1, 0. This one is -5/3. So you can replace. Here, 1, 2, -1, 0. Oh, sorry. Like this. Sorry about that. This one. So was it like first law? Replace by 1, 2, -1, 2, new one, 1, 0, -5/3. 1, 0, -5/3. The second law, 0, -6, and -2. The next, you have the scaling. The second law times the -1/6. What's that? So we have here 1, 0, -5/3. This one is 0, 1, +1/3. What's that? You can change it back to linear system. So this one is related to the x1. This is like x2. So we have x1 equals -5/3. Here, x1 is -5/3. Was it like x2? x2 is, this one is 1/3. x2 is 1/3. So we have it. So what happens? You plug these numbers into here. Was it like a vector b? Vector b is the -5/3 vector v1 plus 1/3 vector v2. So that's it. So this answer is exactly same to previous example by using geometric method. Exactly same. This is like algebraic method. How can you do that? You can change it to the linear system, AX equals B form. The next, so you have to change augmented matrix. You have to use a reduced echelon form. Find X and the X1 and the X2. This is like a final answer. It's like a whole idea. The next, so we think about this problem. A vector B can be written as a linear combination of vectors A1, A2, AN. So if the equation x1, A1 plus x2, A2, and xn, AN, B has a solution x1, x2, xn. Exactly same to the previous result. So here. This is the same as requiring that you can change what? You can think of previous example. Augmented matrix A1, A2 till AN, the vector B has a solution x1, x2, and xn. So this is like an example. Determine if B is linear combination of A1, A2, A3. You can check it. So this one has like linear combinations or not. How can do that? You can change it to this is same to what? Exactly the x1 vector A1 plus x2 vector A2 plus x3 vector A3 equals vector B. So what does it mean? This is exactly same to linear system. The A1 is like 1, 0, 3. The A2 is 4, 2, 14. A3 is 3, 6, 10 times vector x1, x2, x3 equals vector b minus 1, 8, minus 5, just like exact meaning, so like this. So you can use augmented matrix. Augmented matrix, what's that? Augmented matrix is here. 1, 0, 3. We have 4, 2, 14. Third one, 3, 6, 10. Minus 1, 8, minus 5. This is augmented matrix. You can change it to the reduced echelon form. Reduced echelon form. How can change it? You have to eliminate the 3 first. How can do that? This one. This is like third one. This is like first row. Exactly. The third row minus, so plus negative 3 times the first row. The third row is 3, 14, 10, minus 5. The first row is 1, 4, sorry, the negative 3 times 1. We have negative 3 times 1 is negative 3. The negative 3 times 4 is negative 12. The negative 3 times 3 is negative 9. The negative 3 times minus 1 is positive 3. Next, you add these 2 rows. So we have 0, 2, 1, negative 2. So like this. So you can change it to the first row is exactly same. 1, 4, 3, minus 1. Second row, 0, 2, 6, 8. So don't change. So third one is 0, 2, 1, negative 2. The next two. You have to eliminate this 2. Eliminate this 2. So how can you do that? The similar. Third one plus negative 1 times second row. The third row is 0, 2, 1, negative 2. The second row times minus 1, 0 times minus 1 is 0, 2 times minus 1 is negative 2, the 6 times minus 1 is negative 6, the minus 1 times that is negative 8, and add. So we have 0, 0, minus 5, negative 10. So you can change it like this. 1, 4, 3, negative 1, 0, 2, 6, 8, 0, 0, minus 5, and negative 10. The next scaling is this one. You can change it. This middle one is what? 1, 1, 1. The second row times 1 over 2. The third row times negative 1 over 5. You can change it. You can scaling and change. 1, 4, 3, minus 1. Second one is 0, 1, 3, 4. The third one is 0, 0, 1, 2. You have it. The next, you have to eliminate 3, 3. How can you do that? So like this. You have to keep bottom on. What's the second one? This second row is exactly the next one. The third row. The second row, negative 3 times third row. The third row, what happens? The keep 0, 1. The 3 minus 3 is 0. The 4 minus 6 is negative 2. Like this. The third one, similar. How can you do that? Eliminate this 3. The similar. 1 minus first row minus 3 times third row. The top one is keep 1, 4. Doesn't change. 3 minus 3 is 0. The negative 1, the negative 3 times 2 is negative 6. The negative 6 minus 1 is negative 7. Oh, you can keep 4, sorry. The 4 is keep, you have to keep 4. So like this. The next, you can eliminate 4. How can you do that? Here, you have to keep the third row, 0, 0, 1, 2. You have to keep second row, 0, 1, 0, negative 2. So how can you have the 4 here? This is like first row, negative 4 times second row. So what happens? This is like 1, this is like 0, 0. The negative 4 times minus 2 is positive 8. Positive 8 minus 7 is 1. So we have this kind of things. That's good. So what happens from here? Was it like x1? So this is related to x1 is 1. So here, this is 1. x1 equals 1. Was it like x2? So this one is like related to x2, negative 2. So x3 is related to this number is 2. So x3 equals 2. So what's the final answer? So we have this final answer. The vector B. Same to what? You plug this x1 into here. x2 into here. x3 equals to 2 into here. So we have the 1 times vector A1. x2 is negative 2 times vector A2 plus 2 times vector A3. So exactly linear combination. This is your final answer. You got it? This is one good idea. The key part is change to the augmented matrix. You have to change it to the reduce the echelon form, find x1, x2, x3, plug back into linear combination. We have a final answer. This is like a whole idea. The next one. So if vector v1, v2, vp in the Rn, then the set of all linear combinations of the v1, the v2 till vp is denoted by the span v1, v2, vp. This is like exact definition. What is span? The set of all linear combinations of v1, v2, vp. So is called the subset of Rn spanned or generated by V1, V2, Vp. So what's that? The span V1, V2, Vp is the collection of all vectors that can be written in the form the C1, V1 plus C2, V2 plus till Cp, Vp. Was it like Ci's? The C1, C2, till Cp are the scalars, like real numbers. Sometimes a complex number, they're like scalars. This is like the whole idea. So this is a note. The span V1, V2, Vp contains every scalar multiple of the V1. Does it make sense? So because this is the reason. What is like CV1? The CV1 is CV1 plus 0 times V2, 0 times V3 till 0 times Vp. Exactly linear combination. The zero vector must be in span V1, V2, Vp because the what's like a zero vector? Zero vector is exactly same to 0 times V1 plus 0 times V2 plus till 0 times Vp. This is the reason. The zero vector is always in span V1, V2 till Vp. So this is like whole things. The next tip. What's like a geometric description of a span, the one vector V? So like this, you can only plot 3, 4, 5 first. What's 3, 4, 5? Here. You can write this one is like x1. This is x2. This is x3. The x1 is 3 here. x2 is 4 here. x3 is 5 here. You can make the rectangular box, this one, here, and here. We have to make a rectangular box, here, this one, and here. And make the rectangular box, this one. So this point is vector v. You can connect to the origin. So we have it. This is vector v. Was it like a vector 2v? 2v is only twice. You have to expand. The length is twice. This is vector 2v. Was it like a 1.5v? Only half. So here, so this one is exactly 1.5v. Was it like a negative v? So here, going backward. This is vector negative v. So like this. So what is span v? Span v is exactly the constant c times vector v. The vector v is this one. Was it like c times v? Just c equals to only expand twice. The 3 times v is expand 3 times. The negative v is going backward, only reflect about the origin. So what happens? All cv are on the line, the passing through the origin and vector v. This is like idea. So exactly the line is a line passing through origin, passing through v. We can draw the line. The CV is always on the line. It's like a whole idea. So you can explain here. Vector V, 1.5, 2V lie on the same line. The span V is collection of all possible linear combination of V. What does it mean? The C times V, like constant times vector V. So what's that? This is like this. The span V is line through the origin. That's it, just a line. So we know, was it like a span V? Exactly line, exactly line, the line. So we have one good result, exactly line. The geometric description of a span UV, so what's that? Here. The UV and the U plus V all lie in the same plane. Span UV is the collection of all possible linear combinations of U and V. It is a set of all vectors of the form, the C1 times U plus C2 times V. This one. The span UV is a plane through the origin if U and V are linearly independent. Linearly independent, what does it mean? Here, this is vector U. This is vector V. So what's that? So this is like passing through this one. You can draw one plane. You can draw one plane. So this plane contains vector U, vector V. This plane contains vector U, vector V. What happens to U plus V? You can draw parallelogram, the vector U plus V. This is vector. The U plus vector V is exactly on the plane. So what's it like C1 U plus C2 U? Here, this one is exactly the 2 times vector U plus vector V. So what's that? Here, you can draw parallelogram. So this one is exactly same to the vector, the 2 times vector U plus vector V, exactly on the same plane, on the same plane. This is like one geometric result. Span UV is a plane through the origin if U, V are linearly independent. It's a very important thing. U and V are linearly independent. So what happens? U and V are linearly dependent. What is the answer? So what does it mean? In this case, what's linearly dependent? The vector v is sometimes c times vector u. So you can express c1 vector u plus c2 vector v. You can replace. This is into here. So we have c1 vector u plus c2 times c vector u. You can factor out vector u, the c1 plus c2 times c times vector u. Exactly constant times vector u. What's that? This is line. Remember previous one here? Exactly constant times one vector is just a line. The line, the passing through the one point, the like line, the like this. This is like result. This is a very important thing. Linearly independent. Yes, we have plane. So like this, we have a plane. Here, this example. The vector a1, 1, negative 2, 3. Vector a2, 5, negative 13, negative 3. Vector b is the negative 3, 8, 1. Then span a1, a2 is a plane through the origin in R3 because two vectors a1 and a2 are linearly independent. Linearly independent. Was it like b is in the plane or not? What does it mean? Here, vector p is that plane of the span AB. Was it like exact meaning? Exact meaning is the vector p is linear combination of vector a1 and a2. Exactly constant x1 times vector a1, constant x2 times vector a2. This is like exact meaning. The b is that in the plane, the vector b is exactly linear combination. What does it mean? The vector b is linear combination. The vector b is in that plane. But vector b is not linear combination. So b is not in that plane. It's like a whole idea. So what does it mean? You can change this one to the next one. So x1 times vector a1 is exactly 1, negative 2, 3, plus x2 times vector a2 is 5, negative 13, the negative 3 equals vector v, negative 3, 8, 1. Is right? You can change it to the ax equals b form. So we have the first column is this one. 1, negative 2, 3. 1, negative 2, and 3. So this is v2, 5, negative 13, minus 1, constant part, the times the x1, x2 equals the vector v is negative 3, the positive 8, and 1. So we have it. So solution exists. What does it mean? We have linear combination. So B is in that plane. But we don't have a solution. The B doesn't have a linear combination. B is not in that plane. The B is not in that plane. This is like a whole idea. You can check. So this linear system has solution or not. The consistent or inconsistent. You can check these kind of things. You can change this one to the augmented matrix. The same thing. Augmented matrix. As like augmented matrix, the lattice form. So we have here. We have 1, 1, negative 2, 3, 5, negative 13, and minus 1. Constant part is the negative 3, 8, and 1. This is augmented matrix. You can use echelon form. The echelon form. So first, you have to eliminate second one, the negative 2 and the 3. How can you do that? This is first one. This is a second row. This is like a third row. The step 1. The second row plus 2 times first row. So what's that? So we have the negative 2 minus 13, 8. This is like a second row. The 2 times the first row, 1 times 2 is 2. 5 times 2 is 10. The negative 3 times 2 is negative 6, and add it. We have 0, negative 3, and 2. So we have, this is 1, 5, the negative 3. The second row is 0, the negative 3, and 2. The next one, eliminate 3. The third one, the first element, first entry in the third row. How can you do that? Here, third row plus negative 3 times first row. The third row is 3 minus 1, 1. The negative 3 times first row is the 1 times negative 3, negative 3. 5 times negative 3, minus 15. The negative 3 times negative 3 is positive 9. So like this. So we have this one and add it. This is like, let me see. Oh, this typo, sorry. Was A2, negative 3. This is typo. Change it, sorry about that. Here, 3. Negative 3, you add it. This is 0. This is negative 18 and 10. So we have 0, minus 18, and 10. This one. The next two, you can use another echelon form. You can keep first row, keep second row. So you have to eliminate minus 18. How can you do that? This is third row minus plus negative 6 times second row. You can use it. The third row is 0, minus 18, 10. The negative 6 times the second row, the negative 6 times 0 is 0. The negative 6 times negative 3 is positive 18. The negative 6 times 2 is negative 12. You add the 0, 0, minus 2. We have 0, 0, minus 2. So we have it. So what happens? So what happens to this one? This row is next one. The first row, first part, like related to the x1. The second part, like x2. So we have x1, 0 times x1 plus 0 times x2 equals negative 2. What's that? Impossible. It's right, impossible. You can plug any number into x1 and the x2. We don't have the solution of this equation. So what does it mean? No solution. So we don't have any solution. What's that? We don't have a linear combination. So we don't have a linear combination. So conclusion is the vector B is not in the plane span A1, A2. Not in span A1, A2. No. This is like answer of this question, right? The next example. The A1, A2, B is given. For what values of H is vector B in the plane spanned by A1, A2? What kind of some of the H values? So how can you do that? The same. So this is the same to what? So we have here. This is like a span A1, A2. The exact meaning is like the vector B is linear combination of A1, A2 or not. This is like equation. So what's like a linear combination? If we have some linear combination, this is exactly the spanned by A1 and A2. So vector B equal the same. X1 constant times vector A1 plus x2 times vector A2. It's like a linear combination, exactly spanned by A1 and A2. This is the exact meaning. So you can change it to the matrix form. What's that? The same procedure from the previous example. So we can make AX equals B form. What's AX equals B form? So we have here like this. So we have A1 is 1, 0, negative 2, the negative 2, 1, 7, the H, negative 3, minus 5. You can make augmented matrix. The next, you can find echelon form. So this is like a third row. This is like a first row. How can I eliminate the negative 2? So here, the third row plus 2 times first row. The third row is negative 2, 7, minus 5. The 2 times the first row is 1 times 2 is 2. The 2 times negative 2 is minus 4. So h times 2 is 2h. So we have this one and add 0, 3, the 2h minus 5. This is 2h minus 5. So we have this one. Top one is 1, negative 2h. Bottom one, 0, 1, negative 3. So this one, 0, 3, 2h minus 5. The next is here. I can do that. This is like a second row. This is like a third row. How can I eliminate the 3? So we use third row minus the plus negative 3 times. The negative 3 times second row. The third row is 0, 3, 2h minus 5. The negative 3 times the second row, 0, negative 3. The negative 3 times the negative 3 is positive 9 and add. So we have 0, 0, 2h plus 4. This one. So we have echelon form. The 1, negative 2h, 0, 1, negative 3. Here, 0, 0, 2h plus 4. 2h plus 4. This one. What's that? The P is in the plane. The spanned by A1 and A2. So what does it mean? So we have a solution. This one has what? Has solution. It's the exact meaning, has a solution. So when we have the solution here, we can use last one, is like a key part. This is what? 0 times x1 plus 0 times x2 equals 2h plus 4. What's like h? The 2h plus 4 is not equal to 0. We don't have a solution. The 2h plus 4 equal to 0. Yes, we have the infinity many solutions. Sometimes only one solution, depending on. This is like a totally different. Anyway, we have solution. So we have 2h plus 4 equal to 0. Yes, we have solution. So what's the h? 2h equals minus 4 divided by 2. So h equals negative 2. This is the answer of this equation, right? This is the idea. The next, the last example. A1, A2, A3, B. Is it B in span A1, A2, A3? You can check the same. You can change it to the what? Linear combination or not. So B is in span A1, A2, A3. Here, vector B is in the span A1, A2, and A3. So what does it mean? The equivalent to the vector B is linear combination x1, A1 plus x2, A2 plus x3, A3. So for some x1, x2, x3, we have linear combination. In other words, you can change this one to the AX equals B form. So how can you do that? The same. You can change it to this one to the like linear combination. So we have the A1 is 1, 0, negative 2. A2 is 0, 3, 6. A3 is minus 4, negative 2, 3 times x1, x2, x3 equals vector B. The B is 4, 1, minus 4. So like this. So we can change this one to the augmented matrix. Here, you can change it to this one to the augmented matrix. Augmented matrix. Would you like augmented matrix? So we have this one here. So 1, 0, negative 2, the 0, 3, 6, the negative 4, negative 2, 3. Oh, sorry, the erase here. The 4, 1, minus 4. This augmented matrix. You can change it to the echelon form. You can keep first one, first row. You can keep second row, already 0, 0, 3, then negative 2, 1. You can eliminate negative 2. This is like a third row. This is like a first row. How can you do that? The third row plus the 2 times first row. The third row is negative 2, 6, 3, minus 4. The 2 times the first row is 2, 0, negative 8, and 8. You add these two equations, 0, 6, minus 5, 4. So we have it here, 0, 6, minus 5, and 4. The next, eliminate this one. So this one is first row, second row, the third row. You have to keep first and the second row. You can keep 1, 0, minus 4, and 4. We have 0, 3, negative 2, 1, bottom one. So how can you eliminate the 3, the 6 from the third row? So we have this calculation. The third row minus plus the negative 2 times second row. The third row is 0, 6, minus 5, and 4. The second row is the minus 2 times the second row is 0. The 3 times the negative 2 is negative 6. The negative 2 times the negative 2 is 4. The negative 2 times 1 is negative 2. You add these two equations, 0, 0, minus 1, 2. So we have 0, 0, minus 1, 2. So you don't need more procedure. What does it mean? In this case is we don't have a free variable. You are going back to section like 1.2, 1.2. So we don't have a free variable. This is like pivot 1, pivot 3, pivot minus 1. Is right? We have each column has pivot. The pivots. So what's that? The solution exists. This case is we have a unique solution. You have unique solution. What does it mean? Solution exists. The solution exists. So what's that? Yes. The vector B is exactly linear combination. the linear combination. So exactly, the vector B is in the span A1, A2, A3. The vector B is in span A1, A2, A3. It's like a vector. That's it. This is whole idea. Whole idea. If you don't find exact x1, x2, x3, you have to change it. This one to the reduced echelon form. You can change it to the reduced echelon form. Like it's only like exercise. The reduced echelon form is this one. So you can try by yourself. If you want some the more things. So this is 1, 0, 0, minus 4. The 0, 1, 0, minus 1. Here, 0, 0, 1, negative 2. So we have it. So just only exercise, you can try. What happens? First one, we have x1 equals minus 4. Second one, x2 equals minus 1. Third one, this is 2. x3 equals negative 2. So what does it mean? Vector B is x1 minus 4 times vector A1 plus the minus 1 times vector A2, negative 2 times vector A3. Yes, exactly. Linear combination. Vector B is in the span A1, A2, A3. It's like whole idea. Anyway, you don't need more things. Just stop here. Each column has every pivot. That's it. We have a unique solution. The solution exists. So vector B is in the span A1, A2, A3. Okay, this is all for section 1.3. You can watch this video. Any trouble, any question, please let me know. I can help you. Thank you for watching my video. Thanks.